This is the prerequisite review for Section 3.2, Introduction to Polynomial Functions. We have two pretty big objectives here. We will begin with Objective 1, solve equations by factoring. Here we have already factored our polynomial, so we have 3 factors equal to 0, so either x is equal to 0, 3x plus 1 is equal to 0, or x plus 1 is equal to 0. And this is what we call our zero product property. And so x equal to 0 is finished. We will subtract 1 from both sides and divide both sides by 3. And we will subtract 1 from both sides. So here our solution set is 0, negative 1/3, and negative 1. Now, as you can see in number 5, we have two terms and they both have an x in them. So they need to stay on the left-hand side. And here we have a common factor of an x. Factoring an x out, we have an x squared minus 16 is equal to 0. And what we notice now is that we have a difference of squares. We have x plus 4 and x minus 4. So let's go ahead and write that, what a difference of squares is, at the top here. And basically it says that a squared minus b squared is equal to a plus b multiplied by a minus b. So it's kind of important to recognize those difference of two perfect squares. Now we're back to where we were with number 1. So either x is equal to 0, x plus 4 is equal to 0, or x minus 4 is equal to 0. So x is equal to 0, x is equal to negative 4, and x is equal to positive 4. Okay, kind of jumping around here. We'll go to number 2. Again, the same zero product property already factored for us. We have that x is equal to 0, x minus 4 is equal to 0, or 2x plus 3 is equal to 0. So we will add 4 to both sides here, subtract 3 from both sides, and divide both sides by 2. So our solution set is 0, 4, and negative 3/2. Now we'll go ahead and take a look at number 6. Here in number 6, we want to factor out any common factors before we begin. And I see that we have a common factor of an m. So factoring an m out, we have 0 equals m times 2m squared minus 5m minus 12. So here you can see that we have a quadratic that we will need to factor. So this is what we want to recognize that we need to do. So over here, we will go ahead and try to factor that. So two numbers multiplied together that equal a negative 24, and they add together to equal a negative 5. If you're thinking of a negative 8 and a positive 3, that's what we have. We will divide both of these by a 2m and reduce if possible. So now we have m minus 4 and 2m minus 3. So now we have m is equal to 0, m minus 4 is equal to 0, or 2m minus 3 is equal to 0. We will add 4 to both sides. We will add 3 to both sides and divide both sides by 2. Our solution set is 0, 4, and 3/2. I think this might be a 2m plus 3, yeah. You're probably wondering, not a bad mistake to make here, but definitely a mistake. And it was all correct written over there. So this would be a negative 3/2. Okay, very good. Okay, let's go ahead and take a look at number 3, already factored for us. So either negative 3x equals 0, x plus 7 equals 0, or 3x minus 5 equals 0. So dividing both sides by negative 3, we get x equal to 0. Subtracting 7 from both sides, we get x equals negative 7. And now we're going to add 5 to both sides and divide both sides by 3. So our solution set is 0, negative 7, and 5/3. Look at number 7. We can see that we will need to set this polynomial equal to 0 so that we can factor it. So we will subtract 24d from both sides. Now that our polynomial is set equal to 0, what we would like to do is factor out any common factors. So as you can see, we have 3 and d in common for every term. Factoring a 3d out, we have a d squared minus 2d minus 8 equals 0. So factoring that simple quadratic, we have a negative 4 and a positive 2. And we can check that. So you have negative 4d, positive 2d. That leaves us with that negative 2d. Okay, so either 3d equals 0, d minus 4 equals 0, or d plus 2 equals 0. Dividing both sides by 3, adding 4 to both sides, subtracting 2 from both sides. And now we have our solution set is 0, 4, negative 2. Okay, looking ahead at number 4, again, we are going to be factoring, and as you can see, every term has an n in it, so let's factor that out. We have a 3n squared plus 4n plus 1 equals 0, so we will go ahead and factor that. So we have two numbers multiplied together to equal a 3 and add together to equal a 4, and of course it's a 3 and a 1. And then we will divide both of those by 3n and reduce. And as you can see, let's move this over a little bit. There we go. As you can see, we now have n times n plus 1 multiplied by 3n plus 1. So either n equals 0, n plus 1 equals 0, or 3n plus 1 equals 0. Subtracting 1 from both sides, subtracting 1 and dividing by 3. So our solution set is 0, -1, and a -1/3. Looking at number 8, what do you notice? We have 4 terms. And when we have 4 terms, we should factor by grouping. So we will group these first 2 terms together and these second 2 terms together in hopes of finding 2 common factors. So we can factor out a w squared, and we're left with a w plus 5. And let's factor out a -9, and what do you know? We come up with w plus 5 after we factor out. Now we have 2 factors in common. We have w plus 5 in common between the 2 terms. So let's factor a w plus 5 out, and we're left with w squared minus 9. What do you notice here? We have to keep factoring. That is a difference of squares. So we have w plus 5, w plus 3, w minus 3. So make sure you recognize those difference of squares. So either w plus 5 equals 0, w plus 3 equals 0, or w minus 3 equals 0. Subtracting 5 from both sides, subtracting 3 from both sides, and adding 3 to both sides. And our solution set is -5, -3, and a +3. So quite a lot of work here, lots to do, lots of factoring. Okay, now we're going to look at the transformation of graphs, and this should be pretty fast. We're going to be matching. Here are our graphs, and here are our functions, and we're going to be matching those. So let's make a few notes. The first thing you should notice is that number 9. Keep in mind that this is a 0. So HK, the vertex here, would be 3, 0, and it opens up. So do we have a graph here that has a vertex at 3, 0 and opens up? We do. We have D. Maybe I should write that in a different color. Okay, so this is k of x equals x minus 3 all squared. Okay, let's go to number 10. What do you notice? This is shifted down. This is a quadratic function down 4 units. So it used to be centered at the origin, and now it has been shifted down 4 units. So this is B, and this is m of x equals x squared minus 4. Let's go to number 11. As you can see, that vertex is -1, -3, and it opens up. So -1, -3, there it is. And this is graph E. And E is P of x equals x plus 1 squared minus 3. So far, so good. Let's go look at number 12. Try to make this a little bit bigger. 12, our vertex is 2, 3, but this time we open down. And as you can see in A, that's what we have. We have a vertex of 2, 3 opening down. Okay, so that would be A. Looking at number 13, all we know is we have this quadratic function and we have a vertical stretch by a factor of 4. So this is going to be a very, very thin vertically. So it's going to be stretched vertically. And as you can see, excuse me, that's a vertical compression. That 1/4 is on the outside. Why don't I use shrink? And that'll be by 1/4. So it's going to be very, very smushed, or it's going to be wide. The graph is going to widen. And as you can see, that's definitely 3. So this is the opposite, this is 1/4 x squared. And we do know that this is going to open up, since A is positive. So 13 is 1/4 f of x, f of x is equal to 1/4 x squared. This graph here is the same thing. We have a quadratic function, a vertical shrink by 1/4, and then we have a reflection across the x-axis. And we also know that this opens down, since A is equal to the opposite of 1/4. So 14 is definitely F. So I think those transformations really come all together for us once we see the relationship between our quadratic functions and the vertex and the end behavior. And that concludes this section.